All right, so it has been a year since the last FuSa Special Interest Group update at Xen Summit. So this is another update on our latest activities of the last 12 months, or slightly less than 12 months. So there are two major areas that we would like to talk about, as you see on the screen. One is documentation and requirements, and the other one is MISRA C. We're going to go over both of them in the next half an hour. But let me start with a quick introduction. So I'm Stefano Stabellini, and I work for Xilinx. I've been organizing the FuSa SIG activities in the last year. Bertrand, do you want to go next?
Yeah, my name is Bertrand Marquis. I'm working for ARM, and I'm managing a team at ARM working on Xen hypervisor for automotive system and industrial system, together with Luca, Wei, and several other people which are present in this conference.
Okay. Artem, you want to go next?
Yeah. Hi, my name is Artem Mygaiev. I manage a team that works on Xen and EPAM, and I was happy to start the activity long ago with Stefan, Lars, and others. And glad to see it develops.
Luca?
Hi, I'm a software engineer here at ARM in the Bertrand teams. Really glad to be here. Thank you.
Okay, so we'll start with requirement and documentation. So Bertrand, do you wanna cover it?
Go on. Can you go? So, in most safety application, development is based on the V model. So V model is a development process, and in fact, we partly follow its concept without knowing it. So first, we start from high-level specification. This is a description of what you want to achieve from an high-level point of view. Using only this description, someone should be able to write a test to validate the functionality. This is an acceptance test. Then we go down to the system specification, which goes a bit more in details, and high-level designs and low-level design, and finally codings. Each level has its own corresponding tests. So we have three groups: the code, requirements at different level, and different types of tests. Each of these might be done by different people. Some certification standards actually explicitly enforce tests to be done by someone else than the implementer. So in a certification process, from my experience, we spend far more time on writing those requirements and tests than on coding itself. So this is where the major cost of certifications are, which is why we try to work on this for Xen. Can you go to the next slide? So what is a requirement? A requirement is something describing a single function of feature that is testable, measurable, and expressed in a clear way. So let's see some example. Xen shall never crash. It's very clear, it's not ambiguous, but it's impossible to test, which is usually the case for all negative requirements. So that's not an unacceptable requirement. Xen shall support up to 64 cores. This is easy to test that 1, 2, and up to 64 cores are supported, but 65 is not. So this is what a requirement looks like. It's the way to express it is clear and it's not ambiguous. But the way of expression is not really in documentation, but the information is there. Xen supports up to 64 core is what you would expect. So the usual way to express requirement is using words like shall, must, and other keywords which are not usually used in documentation. But we can definitely extract requirements from documentation if we can identify and tag them properly. That's what we are trying to do. Can you go to the next slide? One big part of certification is linking. So what is linking? The goal of linking is to be able to go from one requirement to the test, from one requirement to the design, to the code, and back to the test. It's a very complex and time-consuming task to create those links. The next work is very dense, and not all relations are one-to-one, but many times one-to-one. This is also the first thing checked by any certification authority. They take example and they check the root and the consistency. They are very good to know where to hit and to find issues. Can you go to the next slide? So where to store requirements? The usual way to do that is to use proprietary software. The main one used in avionics, for example, is named DOORS by IBM. That's kind of a 3D Excel table where you write requirements in an Excel sheet and you link it to other requirements and you can browse and go between them. Those kinds of products would be almost impossible to use in an open source project. First, they are expensive. They require quite some knowledge because it's not only a database, it's a linking system with history and so on and so forth. And so developers would not be able to maintain the database even if we were using it. So we choose to take a different strategy. Luca? Luca, you are on mute.
Sorry. So what's the plan here? Basically, we are working in collaboration with the Zephyr project. They did an investigation and a proof of concept using Doxygen. And the goal here is to use the same strategy and tools for both projects, regularly synced together to gain benefit from each other progress. We are going to store our high-level requirement on RST files that can be used later as a documentation. And instead, for the low-level requirements, we are going to store them together with the code. And doing so, it would improve the maintainability, and we can review them as well. Finally, we can use Doxygen to define and maintain links between high-level requirement code and in the future also tests. So to build the overall traceability matrix. And finally, Sphinx can be used to generate the final output. In the next, here we can see the workflow of the tools. Basically, in the first step, we have Doxygen that is parsing the documentation and is creating an XML dataset from the source code. In the second step, we have a Sphinx that is reading RST file, and those RST files can contain reference to the XML dataset, and Sphinx is building all together to create the final HTML documentation. So what's the status now? In the next slide, we have a first patch on the mailing list. This patch introduces Doxygen, and it is also documenting a public header, the ground table public header. Step by step, we are going to move the Xen documentation to Doxygen and preparing everything for requirement extraction. And in parallel, Bertrand is working on high-level requirement document that we are all reviewing during our FuSa meetings. So I don't know, Stefano, is it possible to share the documentation? I prepared, yes. I prepared a web page to see the output of Sphinx of this process. Basically, you can see here the hypercall interface section is replicating the actual documentation. Can you open the grant table page? Thank you. So here we have all the documentation from the source code of the public header directly in the HTML format. And in this page, we can see all the data structure, all the comments that are present in the public header. So every change in the code is instantly reflected in the documentation. And it is also good looking. So now I think I can leave the floor to Stefano or Artem. Thank you.
All right. So the next big topic where we spent our effort is MISRA C. And I'm going to later go through on exactly what kind of rules we are looking at. But before we do that, I think it makes sense to talk about, why MISRA C, right? Why we're even doing this.
Yeah. So first of all, yeah, of course, MISRA or any kind of compliance with defensive programming techniques are required by safety certification. But if you look at the Xilinx, which obviously C is used since then, you see that there's a lots of C itself allows lots of misuse and obfuscation, misunderstanding, and probably most of the defects that are coming to vulnerabilities or to crashes or something are coming from incidental misuse, especially for memory and string handlings. And itself, standard is also far from being like super complete. Even I just went and counted myself the instances of things that are undefined, unspecified, or implementation defined, and there's a huge amount of them. So most of them are either implemented in a very funny way by compilers, or every compiler can treat them differently. And of course, C itself does not have standard, does not have a runtime checking mechanisms. Some compilers introduce that, like boundary checks, optional boundary checks, but that doesn't exist. And with all that, you can imagine, like 30 years ago, that was a big problem for safety industries, especially for automotive. MISRA was established in UK in 1994 with the first paper. Now it's also used by other industries. It's also used by aerospace and defense, by telecom. Medical does a lot of application of MISRA, and rail industry as well. Initially, MISRA was created to address the safety by limiting all of these unspecified and unclear things and eliminate obfuscated use of language. Now it also addresses security issues, potential security issues, because the root cause, it turned out that the root cause of safety issues and security issues are often the same, and reliability, and somewhat, to some extent, portability as well. So basically, MISRA itself is a standardized guidelines for defensive programming, and it implies some coding style that forces some defensive programming techniques. And this is actually good. I mean, defensive programming itself in system critical software allows you to avoid typical errors that may or may not be caught by compilers. I mean, sometimes we see that compiler, by changing version of compiler, of the same compiler, we may start catching some error that we haven't seen before. Or like Xen, we now support GC and Clang, and some errors can be caught by one and will not be caught by another. So also standard like MISRA allows to improve readability. So some very unclear constructs in language are not allowed. So basically, review time shall be minimized when you have this kind of when you follow the rules and style that is applied by MISRA. So again, very important to note, MISRA is not just for safety or whatsoever. MISRA is actually a way to improve, to introduce defensive programming techniques, defensive coding. Stefano? Yeah. So MISRA itself, there's a MISRA for C++, but we talk about MISRA in C. It has rules and directives. Some of them are easy to validate by tools, some of them is not easy, but in general, you can split them in three categories: mandatory, required, and advisory. Advisory is just generic recommendations. Required is something that you need to follow, but it's not necessary if you have a good reason. Like if you have, you can create a deviation saying this is done because this and that, and we know that safety or security or whatsoever is not broken by not following this rule because this and that. So everything is documented and clear, and everybody in the community understand why. And mandatory is something that needs to be followed. And of course, deviations from the required rules need to be stored somewhere, documented and checked, because this is something that assessors, in case of going to safety certification, will be thoroughly checking. And there are different MISRA static code analysis tools, like Coverity, for example, allows doing that, but not the free version, unfortunately. And in a FuSa SIG, we are trying to validate what can be done with a CPP check, which is open source. And of course, there are like lots of proprietary ones that can be used in a broader community, but for safety certification can be used for by the integrator. Yeah, Stefan.
Yeah, we already showed this slide last year. So Resultech did an analysis of Xen using their static analysis tools, looking for violations of MISRA C rules, and the results were actually quite positive in the sense that there weren't that many violations, especially if you consider that the top violation were all false positives. So if you remove the top 4 or 5 false positives here. The remaining ones are actually pretty few. It's actually quite difficult to configure static analysis tools to avoid false positives because you need to make sure all header files are properly included, make sure to tag especially or assembly function because assembly is well outside of what MISRA C covers, and so on. So it's quite easy to get a high number of false positives. So what I wanted to tell you is the recent activities are all around tailoring. And tailoring is a process of looking through the MISRA C rules and guidelines, mandatory, required, and advisory, and finding the set that makes sense for your project. This has been done in collaboration with Zephyr, so as they came up with sort of a group of rules, and we are going through that list, and I'm going to show it to you in a second, one by one to see if it makes sense also for Xen, and also how it can be automatically checked. Because as you can imagine, even agreeing or knowing that a rule is there or should be followed, there are many rules. It's difficult by code review alone to spot all violations. So the usage of a static analysis tool is really important to be able to know if there are issues in code being contributed, for instance. And the good news is that so far, definitely more than half of the rules can be checked by either GCC or CPP check. So when I say GCC here, GCC is very interesting because GCC is a compiler, right? But in the MISRA C world, GCC is not a compiler, it's a static analysis tool. Why? Because as a compiler, the compiler needs to be safety certified itself to be a compiler, and GCC is certainly not safety certified. So it's not a compiler, but has a lot of useful warnings and messages, error messages that tells you about if you're making mistake writing your code. And in that regard, it's really like a static analysis tool. So if you try to compile your source code using GCC minus capital W all, then you get all sorts of warning, and those are really like the Coverity warning or other tools warning. The other tool that surprisingly is providing a lot of checks and is open source is CPP check. So one of the goals that we have is to enhance our GitLab CI to do that today can, and you'll see in the talk tomorrow, can run tests against contributed patch series to also run GCC, or obviously GCC, but also CPP check, and in the future other MISRA C tools checkers against contributed code, so we can spot violations early. Now, this is really what I wanted to show you today, and we have discussed as part of the community many times MISRA C now over the years, and to be honest, most of the time neither us nor nobody really in the room knew what MISRA C really is. I mean, we know what it is in theory, we know what the aim of MISRA C is, but we don't really have a sense of what the shape of MISRA C is, right? What it means for Xen project. Now that we went through the majority of the rules that we have to follow, we have a lot of a better sense. And this is really, I wanted to give you today a sense of what it means to be MISRA C compliant. The first thing I wanted to show you is a document that we are going through. This is an Excel sheet that has a number of rules. These are the subsets that we identified, and we're going through it, checking how it can be, if each rule makes sense, does it make sense for Xen, and how we can automatically check. Is either GCC or is it CPP check? Is it straight C99 compliance? Maybe is missing, or maybe there is a flag for GCC, and so on. Now, obviously, we cannot go through all of this list now, but I picked a few rules and examples to show you to get you a sense of what it means to be MISRA C compliance. So one thing that we noticed to go into the list is that a good chunk of this rule, maybe half of them, actually we already follow. We already follow because they're straight C99 compliance, or is already part of our coding style, either formally or informally. These are things that if somebody contributed code that is not really compliant to one of these rules, we will reject it, even if we didn't know actually it was a MISRA C rule that we are following. And I'm going to give you a few examples of this. This is a rule that says section of the code should not be commented out. And look at one example of a violation. Now, they're not saying you shouldn't have comments or you shouldn't have comments with code. What this rule is really meant to prevent is for people to comment out code instead of removing it and doing a git commit and using git history or version control history to keep the code up to date. Instead, they're simply commenting out the old code and keeping it around, right? So we don't do that in Xen. I think we don't do it anywhere. Now, another example is this one. A project should not contain unreachable code. Now, this seems to be straightforward. Like, for instance, if there is a return statement, we are not going to have another statement after the return statement. Now, here is another rule. There should be no dead code. Similar to the one before, I think the difference is not just about things after a return statement. So here, as an example, there is an increase of a pointer, but then is never used, right? So things like this. So you are working on a variable you are not making use of that variable. This wouldn't pass code review. Another interesting one: project should not contain a news type declaration. Now, for instance, in this case, look at the non-compliant example. There is a type def of something that is never used. Again, we wouldn't do something like that. Another one is a function should not contain unused label declarations. So here the example is there is a label which is never used. And again, if we define a label, we use it. If we don't use the label, we remove the label. So we don't typically have any of these violations. Another is there should be no unused parameters in functions. So if you have a functions with two parameters, it's because you are going to use both of these parameters. It's not like we're going to add a parameter to a function that we're never going to use afterwards. Now, the one I showed you so far are rules that are in a way straightforward. It's obvious their meaning, and we basically are already following them. And if there are exceptions, it's really because there are exceptions, right? We are basically, I think, already following this rule, even so they're not written down in our coding style.
Julian is asking about callbacks on the unused parameter. That's because we have a defined interface. So I think that's one of the cases where you can explain why you have a violation of the rule.
Yeah. I was thinking that too while I was explaining this. What I'm going to show you next, I think, is more interesting. These are rules that we maybe sometimes follow, but not always. But they kind of make sense once you see them. So one is string literals. So I'm going to give you the simple explanation. String literals should be assigned to const pointers. So if you are using string literals like this, you should pass it as a const pointer like this, and not as a straight char star pointer. Do we always do this? Probably not. It does make sense. So, following it maybe is a good idea. There are others like this one. Like, for instance, function type shall be in prototype form with name parameters. Like, in this example, the prototype adds also the name of the variable, not just the type. Now, I think almost always we do this. There might be a couple of occurrences of the other form, but it's not really, I think, the most common one that we have in our headers. I put down two more examples that I think are even more interesting. One, it says, array should not be partially initialized. And that is so that you don't have surprises leaving things uninitialized without, not doing it on purpose. So the goal, like if you use this form to initialize an array, you should initialize all entries, not just some entries. So this is straightforward and makes sense. I mean, if you're going to use this form, do you really want to initialize only some entries? It doesn't seem to be very sound, right? And then changing the code, it makes it very easy to start using uninitialized entries. Again, this is a rule we don't actually have. Might or might not pass code review. Maybe it's a rule that we should have. The final one is even more interesting, I think, because certainly we don't follow. This says that if you are initializing arrays, you should always size the array explicitly, right? The array size should be always explicit. So in this example, this is not allowed, while this is allowed. Why? And this is, again, so that you are sure that you know, what you're using is exactly what you meant to use. You are using an array of 10 entries, so you write down 10. You don't automatically calculate the size of the array, which is considered error prone. Okay, so this is the end of my quick showcase of how MISRA C rules look like. And I hope I gave you a flavor, and please, ask questions if you have any. I see the Julian's yes, that's recent, that's very good. And this is also a proof that GCC is really a good MISRA C checker, right? This MISRA C is checking for this. We can use it as a MISRA C and a static analysis tool to check exactly this kind of stuff.
Yeah, most of compilers are actually doing more checks like the ones that are MISRA recommends, and even Clang is extending the amount of checks. I was checking that recently. So yeah, valid tool.
So the one that we already follow are really, it's really easy to make them more formal and maybe say that we actually follow. The one that we mostly follow, but not always, might require a little bit of a discussion. There are very few rules that we don't follow at all, or we have never discussed any of these, I think.
Yeah, and even then, of course, there will be corner cases, and reading through MISRA forums, you can see like people saying this and that, and yeah, you always can do a waiver and explain the deviation and document the deviation. Why is it like this? Which is absolutely normal process if you're aware of what you are doing. But well, and we are because everything goes through code review. But in some projects that may happen just because the developer were willing to do so, and that may be an issue. Yeah.
Yeah, that's not really meant to catch the cases where you where you thought it through. They're meant to catch the cases where somebody by mistake wrote poor code.
It will also help a lot the review if we have some automatic checking instead of spending a lot of time checking the code. Some rules might be controversial, like adding brackets for single lines after an if. Those kind of things, I think they might require some code changes in Xen, but it's a one shot and should not be too problematic for people developing, I think. But it will create some discussion, definitely.
And the benefit is that through GitLab CI, we will get very thorough checks of all MISRA C rules, and it will be a lot more than what we can do today.
Yeah, I think Julien wanted to speak.
Yeah,
so,
please.
The example about the if, can't we use a compiler for that? I know that on GCC they will one is there is like a misled indentations, which seems similar to what you're trying to do here.
Yeah, but it will not make you MISRA compliant.
Okay.
You will deviate from MISRA and justify it because you check it with the compiler. But even with the compiler check, one might have to anyway change the code if they want to go to certification authority, because that's the typical thing that certification authority will refuse. Because that means you need a manual check of this, because the compiler might not be right all the time. If you have in bracket several if,
it's fair
one
to
after
say
the
so
other.
that it's fair to say so. This one, I mean, having a GCC check will help. It might not cover it all, right? And we might still have to change the code, but it's better than in other cases where there is no GCC checks, right? So, yeah.
But it will be a deviation. We will have to say we deviate from this rule from MISRA, and the justification will be because we use GCC to check whatsoever. That means someone not using GCC would have to do a manual analysis of this, which means probably more work than just changing the coding standard. It's also that MISRA can bring on a standard coding standard to Xen, which could help.
Which would be useful, I think, to have one.
Yeah, it's something missing in Xen. Lots of rules are unwritten.
Okay, so we are over. I don't want to steal time from the next speaker. So thank you guys for attending. And if you have any question, you know how to reach us. Okay.
Thank you.
Thank you, everyone.